Today we're going to talk about the distributive property. A lot of you have probably used this and have at least heard of it before, so this might be a refresher for some of you, and for some of you it might be, it could be new, but I doubt it's completely new. So let's just start by considering the following scenario. You decide you're going to make a combination of M&Ms. You're going to pull out 3 yellows, 2 greens, and 1 red. So I'm just going to kind of write that in a shorter notation here. So we'll write 3 Ys for 3 yellow, 2 greens, and 1 red. So you're going to decide to actually do this, make this combination 4 times, and we would like to know if you make each combination, if you make this whole thing 4 times, how much would you have? So you could write this in 2 ways. You could write it as 4 groups of 3 yellows plus 2 greens plus 1 red. Or you can simply copy it down as an addition problem. So compare the two sides. Which one would you rather work with? Usually the left side is the easier one to work with because it's less writing. But that's what you would have. You'd have 4 combinations of those colors. And so if I wanted to know how many total would you have, well, you would have 4 groups of 3, which would make 12 yellows. You would have 4 groups of 2, or you can just do 4 times 2, and that makes 8 greens. And you'd have 4 reds, which makes 4 groups of reds, or 4 reds total. So distributive property is really like if you just added each of these together and wrote your answer, but it's so much quicker to just be able to multiply that 4 inside to everything because you're going to add each item 4 times. So it's much quicker to just multiply. So that's why we use distributive property. It's really just multiplication. We're actually going to write that down, that distributing is really just multiplying. As we said in the earlier PowerPoint, it's like if I were to write this group that many times and add it together, it just saves us time. So that's why we distribute. So we're going to take a minute and just distribute the following here. So if I have some number A and some other numbers B and C, I can just distribute this A in here because I'm going to be adding this group A amount of times. So A times B, since we don't know what they are, is just going to be AB. I see a plus sign, so I'm going to keep a plus sign because everything is positive. And A times C is simply AC. Now, if we look at number 2, there's actually supposed to be an A right here, so we're just going to add an A right there. So it does not matter if I decide to put the number on the left or the right. As long as the number is side by side with a parenthesis, it still means multiplication. So I kind of do that, A times B, and I get AB. I'm going to keep my plus symbol. And then I'll do A times C, which is AC. And if you look, we get the same answer in both lines, and that's supposed to happen. It doesn't matter if you multiply from the right or from the left, you're going to get the same outcome. So let's try it with subtraction this time. We'll do A times B, which is simply AB again. This time this is a minus. So you can just keep that minus as is, or you can read it as a negative c. Either way, you're going to have a minus in your answer. So if I do just a times c now, I get ac. And again, you can also have your number or your letter on the right side. It still works the same. So you can kind of go backwards. A times b is still ab. And a times c is just ac. So we have to remember this isn't on the right side. This isn't typically how we write distributive property, but sometimes you'll see that, and you need to be aware that you can distribute from right to left. So there's 6 practice problems here. We want to make sure that we have that distributing skill down before we move on to anything a little bit more difficult. So we're very quickly going to distribute these. 3 times x is 3x, and 3 times y is 3y. And I keep this plus symbol because there's a plus symbol in here, so I'm still adding. We're going to actually go down here. Just be careful this time because this is not a 2, it's a negative 2. So I have negative 2 times a. That's going to make negative 2a. Remember that when you multiply a negative and a positive, you will get a negative. Negative 2 times a positive c is a negative 2c. So that's my simplified expression. Again, we have a negative down here, so we're going to distribute, and we'll get negative 20. This time be careful. I'm doing a negative 4 times a negative y. That's going to make a positive 4y. Again, a negative times a negative is a positive. A negative times a positive is a negative. You'll often see expressions like these. What you have to remember is if there's just a minus on the left side of the parenthesis, that's like saying negative 1 times p plus 3. We just don't write the 1 because 1 doesn't change the value. Anything times 1 is itself, so we don't need to write the number 1. But in this case, we will, so you can see it for easier simplifying. Negative 1 times p is just negative p, or you could write negative 1p. It's the same thing. Negative 1 times positive 3 is negative 3. When I look at the next one, I see a number on the right directly beside the parentheses, so I actually have to distribute backwards. So 2 times h is 2h. I'm going to keep this minus sign. And 2 times 4 would make 8. And we're going to do that one more time. If I notice, these parentheses are directly side by side with nothing in between. So that means that I have to multiply. So negative 6 times w is negative 6w. Negative 6 times positive 3 is a negative 18. Or minus 18. The same thing. So we're going to make a little note here that I wanted to point out these are 2 common mistakes I see. The first one reads 4 plus x minus 3. The one on the right reads 4 plus x times -3. So these are different. Okay, we've got to be really careful about that. So the general rule is if you have a negative symbol after your parenthesis, like in this example, you have to treat it like it's a minus sign. So like you have to read it like subtraction. It's not a -3. This is the same thing as saying 4 plus x plus -3. And when you have it separated, you can't multiply because you're not multiplying anymore, you're adding. Whereas if I have the parentheses around the negative, they're telling you you need to multiply by a negative number. So we need to watch out for problems like that. All right, so we're going to look at combining like terms, but instead of, many of you have probably used letters before, like 3x and 4y and 6p and all that fun stuff. But instead of using letters, we're going to start with numbers because letters really are just mystery numbers. So let's say I had 3 groups of 4. I'm just going to show that like this. 3 groups of 4 would be the same as 3 times 4. But I'm going to leave it like that. And to that, I'm going to add 2 groups of 4 squared. Now, I know that 4 squared is 16, but I'm going to leave it as 4 squared. And this is just to show you guys a point. I'm also going to combine 6 groups of 4. So 6 groups of 4. I have 1 group of 5. So you can either write a 5 or you can just write 1 parenthesis 5. It doesn't make a difference. And I have, the last thing I need to add is 7 groups. So 7 more groups of 4. So we could type this all into a calculator and get one final answer. But instead of doing that, I actually want to write down how many total groups of each number I have. So if I want to know how many groups of 4 do I have? Well, I have 3 groups of 4 over here, and I have 6 groups of 4 over here, and I have 7 groups of 4 over here. So if I wanted to know how many total groups of 4 do I have, well, I have 3, 6, and 7. So if I add 3 plus 6 plus 7, I'm going to get 16. So really, I have 16 groups of 4. Now I only have 2 groups of 4 squared, so I can just leave that alone. And we'll do a circle around that. And then I only have 1 group of 5. I don't have any other groups of 5 to add in. So we'll do, let's say, a heart around that shape. So we're just going to add 1 group of 5. So why is this important? Well, I couldn't go any further. I don't want to say, oh, 16 and 2, so there's 18 groups of 4. That's not true. This isn't 4, this is 4 squared, which is 16. It's much bigger than 4. So we don't want to put these guys together. They're different values. We don't want to count them like they're similar groups. So we want to compare this to a scenario with letters. So let's say I have 3 groups of x's. So we'll let x be our 4 here. I have 2 groups of 4 squared, which we'll say x squared instead of 4. I have 6 more groups of 4, so we'll say 6x. Again, we're letting x be 4. One group of 5. Now, since we're letting x equal 4, I'm going to have to make a new letter to represent 5. So let's use y. So 1y. And then I have 7 more groups of 4, or 7 x's. So again, we're letting x equal 4. And y is going to instead equal 5. So I can do some combinations because I have what are called like terms. Like terms will have the same letter and the same exponent. Just like we did over here, 3 groups of 4 and 6 groups of 4 and 7 groups of 4 made 16 groups of 4. Because we're just counting groups of that specific thing. So we're going to draw a box around all of our x terms. And just like before, I add the numbers in front, which are called the coefficients. 3 plus 6 plus 7 will again make 16. Instead of writing 4, I'm going to write x. And we just had a 2x squared. And we had just 1y, or 1, 5. I'm just going to write y here because we really don't need to write 1 in front. Again, 1 times anything is itself, so there's no need to write the 1. So that's something to look out for when we're grouping like terms together. We want to make sure that they have to have the exact same letters and the exact same exponent, or they're not like terms. So we have 8 examples here, and this should not take long. We're just going to circle up our like terms to start out. So I see a 5x, a negative 2x, and another negative 2x. And if you notice, I am including the sign in front of the number, so I don't forget if it's a positive or a negative. And then I'm going to do 5 minus 2, and then minus 2 again, which leaves me with 1. So I would just have 1x. Then I have 4 whole numbers and 3 more. So those are like terms because they both have no letters. And 4 and 3 will make 7. So that really just became x plus 7. Let's go over here to number 2. 17 minus 9 is 8. And 8 minus 2 makes 6 groups of m's. Negative 2 and 7 are just regular whole numbers. And negative 2 plus 7 is positive 5. So if you think you're okay with that, feel free to work ahead here. I'm just going to slowly go through and just write the answers in the work as I make my way through the problems. And if you guys notice, as I'm going through, I'm never changing the exponents when I condense to make with like terms. I'm never changing them. I'm just simply saying how many groups of p squareds there are. So be careful about that. Now in number 5, we have an x and a y. Okay, so we could read that as 5 groups of 2 times 3. So we would need to have both x and y in order to count them as a like term. So I do see another group here. Now this one you want to be careful. Oops, right there, even I made a mistake. This is tricky. Here we go. So I'm looking for any xy's. This does not have xy. This is not xy, but this is. I don't see any other yz's, but I do see xz's, so they can be paired up. So that is your simplified answer. And before you go through and just finish, I do want to point out, if I had a problem that said 2yx plus 3xy, you are allowed to combine these because even though the order is different of the letters, they still both have an x and a y. So they are like terms. The ordering of the letters doesn't matter because when you multiply, it doesn't matter what order, you'll always get the same answer. So looking down here, I see an x squared y term. So let's box that up. We're going to look for any x squared y terms. So here's another one. Now we're ready to combine. And then the last one, I'm going to look for any whole numbers without any letters. And I do see there's one on the end here. Now I'm going to look for m squared n terms. And we'll use boxes for that. So here's an m squared n term. And looks like I have an m term here and an m term here. So 1 and 3 will make 4. -3 and +4 make 1. So I'm going to just drop the 1 and just write m squared n, because again, you don't need to put the 1 out in front. And 4 and -7 will make -3. So notice I'm not going to write plus -3. I can just write -3 because it's the same thing. So in these last examples, we're actually going to put both distributing and combining like terms together. So the key to the first problem is realizing, hey, there's a plus symbol right here. So really, I'm just going through and I'm either subtracting or adding everything. Nothing changes because there's a plus sign right here. It just means combine. I'm going to go through and look for my like terms right away. So there's 3 pairs of like terms. We can put them together. 4 and 2 will make 6. -3 and -9 will make -12. And 6 and -12 make -6. So that's our answer. There's nothing else I can do. Now, in the next one, we have to be really careful. We see the scenario where there's a minus outside of parentheses. And if you remember, we don't use the minus and distribute backwards. We can only go from left to right with the minus symbol. So this is like saying 9y squared minus 2xy plus 3 plus -1 parentheses 2y squared minus 5xy plus 4. So these are saying the exact same thing. We just don't write that 1. That's just how we write it in math class. This is a bit more sophisticated. So anytime you have a minus in front of parentheses, you have to distribute a -1 to each term in the parentheses. So I'm going to have 9y squared minus 2xy plus 3. And now I'm ready to distribute. Negative times positive is a -2y squared. Negative times -5 is a positive 5xy. And a negative times a positive is a -4. Now I get to go through and I get to combine my like terms. So I see 9 and -2 to make 7y squared terms. I have -2xy terms and positive 5xy terms. 5 minus 2 is 3. And last but not least, I have 3 and -4. And those will make -1. And that's it. Now in this one, I do see distributing. I see a 3 with a parenthesis, so I do have to distribute 3 to each number in the parenthesis. So I'm going to get 6x squared minus 12y plus 3. And then I also see a positive 2, so I have to distribute positive 2 to the next parenthesis. Go through and combine your like terms. So we have -12 and positive 8. That makes -4 y's. And I'm stuck with a plus 3. When we look at the last one, again, we have to be careful because I see a negative sign here, a negative sign here, another one, and another one. So we have a lot of negatives going on. And I'm going to go ahead and erase this so I have a little bit more room to write. So negative 3 times 2 is negative 6 xy. Negative 3 times a negative 4 is a positive 12y. And negative 3 times positive 5 is negative 15c. Now in this second part, we want to be really careful. We don't have just a regular 3 out here. There's a minus sign in front of the 3. So we want to take that minus for the ride. So we're going to actually read this as negative 3 and just write our answers down here. Negative 3 times positive 2 is negative 6y. Negative 3 times negative 6 is positive 18. And we would label that xy. I have a negative 6xy and 18xy. So if I had 18 groups of xy's and I lost 6, I would still have 12 groups left. Same idea for the y terms. If I had positive 12 y's and I took away 6 groups of them, I would be left with 6 groups of y. And then I'll just throw in that 15c because there is nothing I compare it with. And that's it. So tomorrow you'll be doing some more work with these, with the distributing and combining. And it could go from left to right or right to left.